Welcome all to the next part of our mathematics series. In our today class, we are going to learn a most beautiful topic is simply called continuity. So as I promised that we are going to learn everything through problems. Even in this lecture also, we are going to repeat the same. I know most of you people are feeling difficulties when you are facing the problems from continuity and differentiability. Now what we are going to do is step by step I am going to derive how to solve the questions directly. Just observe first 2 to 3 questions carefully. Automatically you will be able to solve all other questions. So the first question here, what is asked is, given function is f of x equal to mod x. Okay, so here what we need to do is we have to check whether this function is continuous or not. Check whether the given function is continuous or not. That is the question mark. How should I do this, sir? So let us see the solution for this question. So the step number 1, always in order to check whether a function is continuous or not, we have to do 3 things. First one is we have to define the left hand side limit, and then we have to define the right hand side limit. So let me define these two functions. After that we also define this continuity function exactly at a specific point. What is that specific point, sir? Let me tell you. First, the formula to calculate the left hand side limit is limit x will be approaching to a point A f of x, whereas we are approaching it from left hand side. Left hand side means we are coming from negative axis, so that it will be highlighted by x tending to a power minus. Similarly, if we are defining right hand side limit, it will be defined as limit x will be approaching a plus. Why I am putting a plus here? X axis a plus means we are coming from right hand side. Right hand side means positive, and you can define this function is f of x. So you have to check the value, you have to identify the value of left hand side limit, you also have to identify the value of right hand side limit, and we have to identify the value of exactly at the specific point x equal to a, what is the value of the function. Limit x is exactly approaching at a point a, then what is the value of f of x? Sir, what you are saying, you are defining so many things and we are unable to understand. Yes, I know some of you might not understanding here what I am trying to say. Slowly you will be understanding now. See, let me take the given question first. Let us derive. Let us see the solution for the question. What given it is, the value of f of x equal to mod x. Now, can you please tell me how to rewrite this mod x? How will you rewrite the value of mod x? Mod x can be written as, let me derive it here. Mod x can be written as into two form. One is the value of mod x will be minus x when the value of x is less than 0, and the value of mod x will be plus x when the value of x will be greater than 0. So I have rewrote the function mod x. So this is how we are standardly writing the mod x. After that, now I told you that you have to identify the value of left hand side limit, right hand side limit, and at a specific point what is the value of the a. Now if you observe, what is the specific point, sir? Here I was defining x equal to a minus, x equal to a plus, x equal to a. What is this? Nothing, all are same values only. Let me tell you, see here, if you observe the function carefully, I have defined the value of f of x is going to be minus x when the value of x is less than 0, and it is going to be plus x when the value of x is greater than 0. Of course, I can also define one more point. If the value of x is equal to 0, then directly you can check here. If I will replace x equal to 0, what you will be getting? This value is going to be 0. So I have defined everything here. So first step, always whenever in the question they are talking about continuity and differentiability, you have to identify this specific point. Don't worry, in the first examination, for the when you are facing the first question, you might not understanding what I am trying to conclude. So here I have easily defined that this mod x always defined as plus x when x is greater than 0, minus x when x is less than 0. Of course, it is equal to 0 when x equal to 0. I have been easily defined. For in your point of view, you might be thinking, sir, how you are doing these things. Slowly, after solving 2 or 3 problems, you will be getting the point. So here, let us take the first one, left hand side derivative. Let me take some other color. See, the first one is left hand side not derivative, limit. What I told you, the left hand side limit is limit x will be approaching. Left hand side means you have to write a minus into f of x. Yes or no? Yes. Here what is called a? The point 0. So here we have already defined a is 0. So how to write this function? Limit, just write in the same way, x is approaching 0 minus into f of x. Now tell me, when I am defining left hand side limit, left hand side left hand side limit means negative zone. Negative zone means when x is less than 0, what is the value of f of x? When x is less than 0, the value of f of x is minus x. So substitute that value, limit x is approaching 0 minus, and the value of f of x is minus x. So I am substituting that value here. Now tell me what will be the resultant answer. Now 0 minus means it indicate that we are coming from left hand side to close to that point 0. See, let me define like this. I am selecting a point 0. For this point, if you are traveling from left hand side, then that will be defined as 0 minus. If you are traveling from right hand side, then that will be defined as 0 plus. If you are directly standing at this specific point, then that will be defined as 0 without putting any minus and plus. Directly if you are selecting at this point, if you are standing at this point, then it will be simply defined as 0. So 0 minus indicate that we are coming from left hand side. That's why here also I have written that this is left hand side limit. Okay sir. No, but what is the value? Value of x is 0 only. That minus indicate that we are coming from left hand side. Now if you put x equal to 0 here, it will become minus 0, but we all know fortunately for the 0 there is no significant sign, it will be always treated as 0 only. So we found the value of left hand side limit. Yes. Now it's time to keep our attention with the right hand side limit. Shall we start? Yes. Now you can also repeat, limit x will be approaching a plus f of x, okay sir, will be equal to, simply I can write limit. See, we know the point that the point is what? Specific point is 0. You can observe it here. So the specific points means for the left hand side means always negative value, x less than. Any value can come here. Less than means we are talking about left hand side. Greater than means we are talking about right hand side. Exactly equal to means we are talking about the center point. So here we are facing 0, but it is not true in all other problems. We may also get some other values. We will see soon. Fine sir. So right hand side limit means again we are approaching to 0 only, but I am approaching it from right hand side. So this can be defined as limit x equal to, x is tending to 0 plus f of x. Now can you please define when the value of, when I am approaching this value from right hand side means greater than 0. When x equal to greater than 0, what is the value of f of x? F of x equal to x. So you can substitute the value of x here. For your understanding, I am putting brackets. This bracket is not required actually, right? Now you can substitute x by 0. What you are getting? It will be once again 0 only sir. Now the last point. See, we found the value of left hand limit. We also found the value of right hand not derivative limit. Now it's time to explore exactly at x equal to a, what is the value. Now this is third one. So first one is completed. Second one is completed. The third one is exactly at x equal to a. In our question, a equal to 0. At this point, what is the value? If I am defining limit, x is directly approaching 0, and what is the value of f of x? If I am directly putting x equal to 0 into the given function, so for this, at the specific value, for this you can directly substitute the value of x equal to 0 into the function. Already I have done that. So the answer is, for this one is 0. Now from this I can write down the conclusion. See, keep your attention. Left hand limit, right hand limit at the specific point, all are equal or not? Yes sir. So the conclusion here, what I can write is left hand side limit, that can be derived as limit x is approaching from 0 minus into f of x. This value, what we got? 0. That will be equal to limit x is directly approaching at 0, that is a specifically defined point, that is the last one. This will be equal to limit x will be approaching from right hand side limit with the f of x. See there, all the values are equal or not? Yes sir, all these values are equal. If your given function satisfied this condition, if your given function satisfied this condition, then that the given function is always continuous. So what is the conclusion? The question is, we are requested to calculate the value of whether the f of x equal to mod x is continuous or not. Now you can write down, yes, this function is always continuous. This function is always continuous. That's all. That is the correct answer for this question. Okay. Shall we take the second one now? So let us take the second example. Okay, let us do one thing. I am just giving the second example as the homework question. You can try. So let us take the second example. First you can try. In the next lecture, I will be giving the answer for your question. So the value of f of x equal to mod of x plus 1. Now all I wanted to know is whether this function is continuous or not. So take your own time, use your mastermind, try to bring the answer. If you are really loving our lectures, if you are really understanding, if you are learning something from here, just don't forget to click that like button and share our video with all your friends. Thanks for watching.